So we're starting Unit 9, which is redox. Redox, the RED, the red, stands for reduction, and the OX stands for oxidation. So these are oxidation reduction reactions, or redox. This first part is part of standard 9.1, so we're just looking at oxidation and reduction, and it will take us a couple lessons to get through this. So the first thing is being able to tell oxidation states. Oxidation states enables us to keep track of the electron density in a compound. So how many electrons are in the electron cloud, where are they located, and then how it changes during a reaction. The first thing that you want to do is, so you have to know these rules about oxidation states or oxidation numbers in order to be able to indicate what it is in a compound. So first off, all single atoms are 0. So if we just have sodium reacting, that would have an oxidation number of 0. If it was fluorine, which is a diatomic, it still has that oxidation number of 0. Simple ions, it's the same as the charge on that ion. So if we have an ion of sodium, which has the +1 charge, then the oxidation number is +1. If we have oxygen, which is 2-, then the oxidation state would be -2. So this brings something up. When you write a charge, you write the number and then positive or negative. When you write oxidation numbers or oxidation states, you need to write the positive or negative and then the number. So the order that you're writing these does matter to IB. So just keep that in mind. So in a neutral compound, all states must add up to 0. So if we had like sodium chloride, sodium would be +1, chlorine would be -1, and if we add that together, it's neutral, just like the compound. If it's a polyatomic, then it has to add up to the charge. So if we had hydroxide, for example, oxygen is a -2, hydrogen is a +1, and if we add that together, it would leave us with the -1. Group 1 atoms are always +1, so that's how I knew the sodium was going to be +1. Group 2 atoms are always +2, and they have the same oxidation state as their charge because of how reactive they are. Fluorine, being the most reactive nonmetal, is always the -1. Oxygen is -2 unless it's a part of a peroxide. So peroxide is a polyatomic. It's O2 with a -2 charge. So that's when oxygen's oxidation state would be -1. Hydrogen gets a +1 when it's with a nonmetal and a -1 when it's with a metal. So you have to know these rules and then mentally go through them as you're looking at different compounds. So we're going to practice. All right, H2SO4. You have, this is the way that I was taught how to do them, and I think it makes sense. We're going to create a chart above H2SO4. So if you're using notebook paper, you could do this on 2 lines. And then we're dividing the chart into H2S and O4. At the very top, number or state right above the element, and we're going to put the total at the top. So we would add these numbers, these 3 numbers, and then it would have to equal either 0 if it's a neutral compound or the charge if it's a polyatomic. Because there's no charge on this compound, it has to equal 0 because it's neutral. Then we mentally go through the list. Well, it's not an atom by itself. It doesn't contain a group 1 or a group 2 metal. There's no fluorine. There's oxygen though. So oxygen is a -2 unless it's a peroxide, and this is not a peroxide, so it's going to have the -2. There's 4 of them, so each oxygen has an oxidation state of -2. So 4 times -2, that makes a total of -8. And then we have hydrogen, which is bonded to a nonmetal, so it's going to be +1. There's 2 of them, so total that would be +2. So we don't have any rules about sulfur because sulfur can have different oxidation states, so we have to mathematically figure it out. So if I have +2 plus x minus 8 to equal 0, what does that middle number have to be? Well, to balance out the -8, I would need +6 and a +2. So sulfur, since there's only one of them, has an oxidation state of +6. So these are the answers. These are the oxidation states. Let's do another example. SO3 2-. All right, so we're going to draw our chart. This time we can divide it into 2. We have our total on the top. We have the oxidation state on the bottom. And then mentally go through your, one more thing before we do that. We have a charge this time of -2. So the total then is going to add up to be -2. All right, and then mentally go through your list. No group 1, no metal in group 2, no fluorine. We have an oxygen though. And this is not a peroxide, so oxygen is going to be a -2. There's 3 of them, so 3 times -2 is -6. So what do I need to balance the -6 with to be left over with a -2? So we would need a +4. So this time, sulfur's oxidation state is +4. There's the answer. All right, let's look at another one. This one looks a little bit more complicated, doesn't it? All right, so we have CO, NH3, 6, and all of that has a charge of 3. So when I divvy up my lines, I have H, I have N, and I have CO. The total is going on the top. Oxidation states go on the bottom. Because I have a charge here, the total is going to have to equal a +3. So I mentally go through my list. I have no metals in group 1, no metals in group 2. I don't have fluorine. I don't have oxygen, but I have hydrogen. Hydrogen is next to a nonmetal, or it's bonded to the nitrogen, which is a nonmetal. So that's going to be a +1. 6 and 3. So I have 6 sets of 3, or 18 hydrogens. 18 times 1. So that's +18. Then I have to look at my nitrogen and cobalt. We have an issue here. Neither of them have a rule for oxidation states. But what I do know is that NH3 is ammonia, and that's a neutral compound. So if I come over here and say, okay, that was a +1, that makes a grand total of +3, and it's got to be a neutral compound for NH3, that means my nitrogen is going to be -3. So I can pull that piece out. So if you have a polyatomic, you can pull that out. So this is going to be -3. I have 6 of them, so that's going to be a -18. So what does cobalt have to be in order to have this charge of +3? Well, it's got to be +3 then. So there's the oxidation states. That one was a really hard one. All right, so try these two. Pause it. Try them on your own. All right, nitrogen, that's the element by itself. So its oxidation number is 0. We know that because it's neutral. There's no charge there given, so the nitrogen can't carry that -3. It's got to be 0. All right, and then we have MnO4-. So when I do my chart, the total has to equal -1. Go through your list. Nothing from group 1, nothing from group 2. No fluorine. I have an oxygen. It's not a peroxide, so this is going to be -2. There's 4 of them, so that's a -8. So to have one negative left over, we would need this to be a +7. So this time, manganese has an oxidation state of +7. All right, we're going to do one more. Dichromate. Make your chart. Top is the total. Bottom is the oxidation state. It has a charge, so this is going to have to add up to be -2. And then go through your rules. There's not a metal in group 1, there's not a metal in group 2, there's no fluorine, but there is oxygen. Oxygen has an oxidation state of -2, as long as it's not a peroxide. There's 7 of them, so 7 times -2 is -14. In order to have a -2, that would mean I would need a +12. Now look at this, there's 2 chromiums this time. So each chromium would have to have an oxidation number of +6. So when you go up, you multiply, and when you're coming down, you need to divide by your subscripts. So each chromium has a +6 to give us that total of +12. Okay, one more. Let's, all right, let's try OF2 and see what you would do. All right, the top is the total, the bottom is the oxidation number. It's going to add up to be 0 because it's neutral. Go through your rules. No metal in group 1, no metal in group 2. Oh, there's fluorine. Fluorine has to be a -1. There's 2 of them. 2 times -1 is -2. So we have this instance where oxygen, in fact, is not going to be a -2 and it's not going to be a -1. You have to follow your rules. And once you've hit the rule that leaves you with 1, you have to follow it. You have to mathematically make it correct. So here, oxygen actually has a +2 charge. In other words, the electrons in OF2 are going to go to the fluorine, and oxygen's electron density is going to be, in fact, positive because fluorine is so electronegative, it's pulling those electrons away. All right, make sure you fill out the Google form with your name and any questions you have, and try the problems out of the textbook. But the Google form is how you get marked for attendance.